Good afternoon. My name is Parker Lusk, and today I'm going to be talking about lead contamination in water. Lead contamination has serious implications and health risks, particularly for children. It affects the brain, the central nervous system, the kidneys, liver, bones, reproductive system, and many other bodily functions. It's becoming more and more of an issue because of popular or more notable things in society, such as the Washington, D.C. lead crisis in 2001, where lead limits were found to be 18 times higher than the EPA's limit for detection, and also the more recent crisis in Flint, Michigan. So what do we do about it? There's becoming more and more of a need for citizens, private citizens, to test their own water to make sure it's safe for them to drink. So what my goal and other researchers here at Tennessee Tech, our goal is to develop a sort of sensor. And the way we want to do this is with gold nanoparticles. We want to use gold nanoparticles that have a specific coating that whenever there's lead contamination in water, it will change color. So you know right there in your own home that you have contamination. So how does this work? As I said, this sensor would use gold nanoparticles. Now, nanoparticles mean it's on the nanoscale. So 10 to the 9 nanoparticles are in 1 meter particle. So they're really, really small. Now, because they're so small, they actually have really interesting behavior. Normally, gold is gold colored, but gold nanoparticles are actually red. And we can use this red color to indicate when things happen in the solution. So if it changes from red to another color, we know that there's some sort of contamination. The most popular methods using gold nanoparticles to detect lead involve what's called a DNA zyme. But we're trying to investigate ways other than that, because the DNA zyme is expensive, it's really hard to replicate, much less do in your own home. So our method is to use one of two molecules, glutathione, GSH, or 11-mercaptoundecanoic acid, which we call MUA for short. So one of these two molecules can attach onto the lead, can attach onto the gold nanoparticle, and then the other end would be free to react with the lead. So we have these two functionalizers that we need to figure out which one is the best. So the way we do that is with sensitivity and selectivity. Sensitivity is exactly what it sounds like. How sensitive is the sensor? How small of contents of lead can it detect? The lowest that it would have to detect is 15 parts per billion. So that's for every 1 billion molecules, 15 of them are lead. So it's really, really low concentrations, but that's the lowest it would have to detect. The other thing we need to look at is selectivity. So ideally we want our sensor to only show when there's lead present, because there's a lot of things that are dissolved in regular tap water. We don't want anything to give a false positive. So once we decide which is the most sensitive and selective, we can then move on. And what we want to do from there is take the nanoparticles and put them in a membrane. A membrane is just basically like a filter. It has holes for the water to go through. So ideally, whenever lead-contaminated water would pass through this membrane, it would change color. So once we figure out how to get these nanoparticles in a membrane, we have to understand, will they behave the same way as they do when they're in solution? So obviously there's a lot of things that need to go into this research, but right now we have a plan. So imagine the future implications of this being, you have a Brita filter in your home. You know, there's a little red window on it. And it's red most of the time, but then all of a sudden it turns purple. As soon as it turns purple, you know there's lead contamination in your water and you have to do something about it, rather than going months and months and months before someone tells you you've been drinking contaminated water. So, in conclusion, there's a growing need for detection of lead in municipal water. There's not a question of if it will happen again. There's a question of when will it happen again. And from that, are we going to be prepared when it does? Here are the references that I used for my presentation. Thank you.